Hello friends, today we'll discuss the unit number 2 of the high voltage engineering. The topic is mechanism of the breakdown in the liquids. Basically, liquids are used as a dielectric in the different devices like transformer, circuit breaker and other kind of devices. Basically, the we have to discuss the breakdown the liquid dielectrics. Before that, we will discuss where they are used. The liquid dielectrics are primarily used for filling transformer in circuit breakers. For transformer, liquid dielectrics is used both for the providing insulation as well as a cooling purpose, because during the operational transformer will produce heat and that heat will be taken away with the help of this dielectric. Similarly, in case of the circuit breaker, besides providing the insulation between the live parts and the grounding parts, the liquid electricity is used to pinch the arc that is developed between the circuit breaker contacts. The three most important properties of the liquid dielectrics: the first one is the dielectric strength, the second one is the dielectric constant, and third one is the electrical conductivity of the dielectric. Other important properties are viscosity, thermal stability, specific gravity, and flash point, etc. The most important factor that affect the dielectric strength of the oil are presence of fine water droplet in fibrous impurities. The presence of even 0.01% of water in the oil bring down the dielectric strength to 20% of the dry oil value. In the presence of the fibrous impurities bring down the dielectric strength much more sharply. Hence, to use the liquid as a dielectric, it must be away from these kind of impurities. The main consideration in the selection of a liquid electric is its chemical stability. The other consideration are cost, the saving in space, accessibility to environmental influences. The use of liquid electric has brought down the size of equipment tremendously. When we are using as a air as a dielectric, the size of the devices was much more higher. Hence, with the application of liquid dielectric, the size of equipments has been gone down tremendously. This is a table in which the different liquids like transformer oil, capsule oil, cable oil, and silicon oil. The silicon oil is used for the high temperature operations devices. The liquids that are chemically pure, strictly simple, and do not contain any impurity, even the traces of one in 10 to the power 9 are known as the pure liquids. In contrast, commercial liquids used as insulating liquids are chemically impure and contain mixtures or of complex organic molecules. In fact, their behavior is quite erratic. No two samples of the oil taken out from the same container will behave identically. Hence, we should take care of all these kind of things before using these liquids as a dielectric for devices. The main theory of liquid insulation breakdown is less understood as of today as compared to the gases or even solids. Many aspects of liquid breakdown has been investigated over the last decade, but no general theory has been evolved so far to explain the breakdown in liquids. Investigation carried out so far, however, can be classified into two school of thoughts. The first thought is considered that the breakdown in the liquids on the model, which is an extension of the gaseous breakdown based on the avalanche ionization of the atom caused by the electrical collision in the applied field. Means this is very similar to the breakdown in the gases and extension of the gas theory. While the second school of thought consider that the presence of foreign particles in the liquid insulation has a significant effect on the dielectric strength of the liquid dielectrics. It has been suggested that the suspended particles are polarizable and are of higher permittivity than the liquid. The first one is the electronic breakdown that considered for the breakdown of the liquid electrics. Once an electron is injected into the liquid, it gains energy from the electric field applied between the electrodes. It is presumed that the sum of electron will gain more energy due to the field than they would lose during a collision process. We'll assume this theory to consider the electronic breakdown. These electrons are accelerated under the electric field and would gain sufficient energy to knock out an electron and thus initiate the process of avalanche. The threshold condition for beginning of the avalanche is achieved when the energy gained by the electron equal to the energy lost during the ionization process. And it can be written as equation like E lambda E should be equal to the CHV, where E is the applied electric field, lambda is the electron mean free path, HV is the quantum of energy lost in the ionization the molecule, and C is the arbitrary constant. Thank you. The next thing we'll discuss in the next part.